गेट 2021 का काउंटडाउन शुरू हो चुका है एंड नाउ वी आर इन द एंड गेम।
इतने सारे चैप्टर्स, इतने सारे सब्जेक्ट्स, क्वेश्चंस लगाएं या थ्योरी पढ़ें, लॉट ऑफ थिंग्स आर गोइंग इनटू माइंड।
आप सोचते क्या पढ़े क्या छोड़े, कहां से पढ़े किससे पढ़े। Unacademy brings you a new crash course where you get complete syllabus with best solutions.
आपको मिलेगा हर क्वेश्चन का जवाब हमारे नए क्रैश कोर्स उम्मीद में।
एक कंप्लीट सीरीज विद फुल सिलेबस, होंगे 10 बेस्ट एजुकेटर जो मिलके बनाएंगे आपकी जिंदगी को आसान।
35 दिनों में कंप्लीट सिलेबस विद बेस्ट क्वेश्चंस,
सारे सब्जेक्ट्स बस एक चैनल पे, तो देर किस बात की, हो जाओ तैयार गेट 2021 को क्रैक करने के लिए।
तो मिलते हैं 20 दिसंबर को, लिंक इन डिस्क्रिप्शन।
लेट्स क्रैक इट। सबसे पहला क्वेश्चन या
एक ओवरऑल अपने पास सिनेरियो ये बन गया।
इलेक्ट्रिक फील्ड का फंक्शन क्या होगा?
Then it will be off. Hello guys, good morning, good afternoon. Welcome to the session of network crash course. Welcome, good afternoon everybody. I hope you are enjoying the day. So let's start the session. Let me introduce myself. This is Bhima Shankar. I did my MTech from IIT Kharagpur. I have around 10 years of teaching experience in GATE and ESE throughout the country. I am expertised with the subjects of digital circuit, network analysis and microprocessors. So the last 10 years I came across several thousands of students from every corner of the country. Now I am here to give you the complete crash course on digital network analysis, which is completely free for you. I am very happy to share my knowledge which is free for you definitely. So enjoy the class guys, let's start. So this is my profile name in Unacademy. You can go through my profile name, you can follow it. Really we are going to the best possible special free classes. Today morning we have taken the special class on sequential circuits, yesterday AC analysis. Like that every single day we are taking the free special classes at morning 9:30. You just follow my profile, you will get notification. So yes, we are going to start. I hope you have seen the video. Umeed crash course, that is starting from 28th December. Okay. So all our total best possible team in the country is giving you the best possible content in all possible ways guys. So don't miss that. So let me speak a few words about Unacademy Plus subscription. Sir, what is Unacademy Plus subscription sir? What is the use of it? Let's discuss it. So पहले आप अभी तक Unacademy ऐप डाउनलोड नहीं किया तो जल्दी से Unacademy ऐप डाउनलोड करो। इसके बाद क्या करना, see here, first watch the free special classes. You can watch my profile there, you have best possible free special classes. इसमें you will understand how interactive is our learning platform. It is the best learning platform or best interactive learning platform which will give you the feeling of one-to-one learning. So the YouTube lectures are free for you, special classes are free, quizzes are free for you. If you take Plus, you will have extra advantage like structured schedule where you will be knowing it when the subject will start, when the subject will complete. For your total preparation it will be an extra edge. Live classes, and also you can watch them in recorded any number of times. You have the classes in both the languages, English and Hindi. You will be having multiple courses like crash course, rank improvement, comprehensive, different courses are available. Once you join, you need not pay every single time to all the courses. Once you join, it is enough, that is you will be having the access to all the courses of Unacademy. For example, yesterday 21st December, one new batch is started for 2022 guys and also 2023. So you can join that now itself, okay, and later you can join the other batches also. That is, there is no restriction, whichever batch you like it you can continue, okay. So once you join now, you can access the previous classes, upcoming batches also. So if you join guys, don't miss to apply the coupon code. I know whenever you join, don't forget to apply the coupon code Shankar10, okay. So you will be having regular exams, unlimited test series is free for you, doubt solving sessions after every 3 sessions, 1 session is completely free. These are all benefits of the Plus subscription. If you go for Iconic, you will have extra edge with a personalized digital coach available for you. He or she will take care of you in a personalized way. One coach will be assigned for you. She will or he will take care so to reach your destination in a proper structured way, so that they will be planning your study plan and they will analyze your performance based on your performance of the study, what we call exams, all those things is extra personalized guidance chahiye to you should go for Iconic subscription. So these are the price details for the Plus subscription. If you go for Plus subscription, so don't forget to apply the coupon code. Don't think just any code. If you like the teaching of me, you want to join Unacademy, use my coupon code. If you really like me, you can use the coupon code for Plus subscription. This is for total GATE and ESE. That is the best possible classes from me and my total team, or in fact any class of Unacademy you can access using this coupon code. Okay, these are the original prices. But if you apply this code, you get 10% discount. And you will get, 1 year is for example 30,250 na, you will get it for 27,225. Here it is 38,500 for 18 months, you will get it for 34,650. So for 18 months, this is the best one. That is for third year students, it will help. For second year students, don't delay your preparation by any chance. You can go now itself. Originally 44,000. After applying this coupon code, you will get for 39,600. Similarly, for 2 years, for Iconic subscription, you have 2 choices, 1 year and 2 year. It is 50,250 and 74,000. After applying the coupon code, you will get 10% discount of 5,000 and here 7,400, and you will be getting it for this particular price of for 1 year and 2 years. Right? So why to delay? Let's start our network analysis, equivalent circuits problems. Yes. Namaste Sharma. Okay, Sanchita. Mahesh, good afternoon. Priyanka, Sid, everybody, good afternoon. Santan, good afternoon. Okay, today my aim is to complete the first chapter, that is the basics part. Let's try to complete it, guys. अच्छी बात है, कल का क्लास है छोड़ दो अभी. All these problems we discussed yesterday class. I have given this homework. This one is the question. What is the answer? Comment karo. What happened? Just 1 minute. Yeah. Comment your answer. Everybody, yesterday I gave this question as homework. I have given 424 maybe. This is 442. Otherwise I will do it. So how to find the resistance of the network? I told you apply the voltage V. Assume the current I is flowing. The resistance between AB is equal to V by I. Simple. So parallel voltage is same. Here I1 equal to I. You tell me here 4V. 4I1 can be written as 4I. This node voltage is V. So apply nodal analysis at the node V. Okay. So V minus 4I by resistance V by 2 minus I equal to 0. Take LCM. V minus 4I plus 2V minus 4I equal to 0. 3V equal to 8I. 8 by 3 equal to your V by I. That is the resistance between AB. Okay, that is the resistance between A and B. Resistance offered between the terminals A and B is 8 by 3 ohms. It will work like a load resistor of 8 by 3 ohms. If you have only dependent, no independent, it will just act like a dead network, or we call it as a load impedance or load resistance. Let's do it. Just a minute. Okay, let's try this question now. Let's try. You people try and tell me the answer. Is it visible? Right. So this is the question given by examiner. You people just give a try and tell me the answer for the current I. What is the current I? Okay. So give me your answer. Good afternoon, good afternoon. Chalo, I will do it. Very simple question. Examiner has given this information as 1 ampere. Please listen here. If you take this node as X, this node as Y, इस वाला node को X ले लो, इस वाला node को Y ले लो, ये Y यही P पे है ना, this is also Y only. That is, you see, this is a shorted na, both are Y's only. Now ध्यान से सुनो, between X and Y, what is the resistance? 2R. Here also it is between X and Y. So all these three elements are connected in parallel. In parallel, voltage must be same. By current division principle, if resistance is in the ratio of 1:2, current should be in the ratio of 2:1. Similarly, 2R are in parallel. Parallel में resistance same है तो आपका current same होना चाहिए. That is 2 ampere, 1 ampere, 1 ampere पूरा कितना होता है सर? 4 ampere. ठीक है सर? Now listen here. If this is I, what is this drop? I into R. ठीक है? So this is 4 and here what is the drop? 12R. Simple, apply the loop equation here. आपका problem हो जाएगा. पॉजिटिव टू नेगेटिव क्या होता है सर? KVL अप्लाई किया तो -IR. नेक्स्ट, व्हाट इज दिस ड्रॉप? 2 into R. दिस इज 2R. ओके, सो नेगेटिव टू पॉजिटिव प्लस 2R. ओके, देन नेगेटिव टू पॉजिटिव प्लस 12R equal to 0. What is your IR? Is 14R. What is I? 14 ampere. Simple question. Okay. If you know this branch current, by current division principle, if resistor is in the ratio of 1/2, current should be in the ratio of 2/1. Okay. Here drop is 2R and here also drop is 2R. Okay. So then parallel में voltage should be same. That is the another way you can say. Then here IR is the drop. Here if it is 1 ampere, this is 2 ampere. This is 1 hai, so this should be 1 because two resistors are parallel and equal. So total is 4. Then I applied KVL. Okay. Right. Let's go to the next question. Right. What is the next question here? The power absorbed by the 6 ohm resistor is 0. Then determine the value of the voltage source V. ठीक है? In the network shown in the figure, the power absorbed by the 6 ohm resistor is 0. Determine the value of the voltage source V. Let's do it. Right. Now listen carefully. Examiner has given the power consumed by the 6 ohm resistor is 0. So what is the power consumed by the 6 ohm resistor is given by current in the resistor whole square into 6. As per examiner ये वाला पार्ट 0 है. इसका मतलब क्या सर? मेरा IR 0 होना चाहिए. ठीक है सर. Let's take this node voltage as V1 और ये वाला नोड को ले लो V2. ये वाला करंट कितना सर? 0. ध्यान से सुनो. अगर ये करंट 0 है तो मेरा पास कुछ करंट है, ये ऐसा आया, इस पे करंट 0 है तो सेम करंट इसमें भी चलेगा. What does it mean? These two elements are connected in series. Similarly, if this current is 0, these two elements में same current चलेगा ना, इसलिए ये दोनों सीरीज में है. अगर ये 0 नहीं है तो ये दोनों सीरीज में नहीं है. Because this is 0, these two are in series. When they are in series, you can apply voltage division principle. ये current 0 नहीं है तो voltage division principle applicable नहीं है. That is when you have different currents here, then current voltage division is not applicable. It is applicable because this current is 0, these two are in series. So another, now since the current in the resistor is 0, मैंने बेसिक्स में बताया whenever the current through any passive element is 0, दोनों voltages सेम होना चाहिए. That is voltage drop 0 है ना, V1 equal to V2. ठीक है सर. आपका V1 क्या होता है सर? पूरा वोल्टेज इंटू दैट पर्टिकुलर इम्पिडेंस बाय टोटल इम्पिडेंस. ये आपका वोल्टेज डिवीजन प्रिंसिपल है. 20√2 एंगल 45 आएगा. दिस इज A+JB का कन्वर्शन आप लोग पता होना चाहिए. √A² + B² tan इनवर्स B/A. ठीक है सर. ये तो आपको बताया ना पोलर रेक्टेंगुलर वाला. व्हाट इज दिस? √A² + B² एंगल tan इनवर्स B/A. ठीक है सर. रेक्टेंगुलर टू पोलर कन्वर्शन वाइस वर्सा. ठीक है. चलो ये आपका V2 है. बट व्हाट इज V2 सर? आप फिगर देखो V2 क्या होता है सर? दिस वोल्टेज, ये वोल्टेज कैसा निकल सकते सर? V × 5/5 + 5 दे दो, आपका V/2 आएगा. सो V/2 इक्वल टू 20√2 एंगल 45 डिग्रीज होता है. ओके. 1 मिनट 1 मिनट. इसका कैलकुलेशन करो. ये तो 10√2 आएगा. 10√2. ओके. देन व्हाट इज V इज 20√2 एंगल 45. इस √2 के बारे में कुछ चाहिए, आई मीन ये एंगल का मतलब क्या है, वो सब हम एसी एनालिसिस में भी कल क्लास में डिस्कस करेगा, फेजर रिप्रेजेंटेशन वगैरह. ठीक है. चलो आपको कुछ डाउट है तो बताओ, नहीं है तो मैं आगे चलेगा. ठीक है. कुछ डाउट नहीं तो आगे चलेगा. दिस इज अ वेरी गुड क्वेश्चन. It is given in GATE 2017 for 2 marks. ठीक है. 2017 GATE में दिया ये वाला क्वेश्चन 2 मार्क के लिए. So let's do it. मेरे पास द वोल्टेज V है, 2 रेजिस्टर्स ऐसा है R and delta R. Read the question carefully. If the network shown in the figure unbalanced, okay, bridge is unbalanced by some delta. जो नेटवर्क दिया ना, नेटवर्क में ब्रिज अनबैलेंस हो गया with the value of delta R. अगर सारे R है तो bridge is balanced. Now which is measured with the millivolt meter of resolution कितना 0.1 millivolt. Okay, determine the minimum value of delta R that can be detected. Have you read the question and understand the question? Okay, V1 equal to V2, please listen. Whenever the current through any passive element is 0, that is बीच में source नहीं, passive element होना चाहिए. It should be a passive element. When this element is having 0 current, these two voltages are same. We have discussed it in the basic classes. Please attend that, you will get the clarity. Okay, because there is no drop here, voltage here must be compulsory same. There is no potential difference between these 2 points because the current is 0. बीच में whatever you can have, it is same. Not for sources. It बीच में you should have elements. Okay, that elements should not have, will not have any drop. That is the concept. Now go by this question. Okay, is it fine? Current source का voltage is undefined, Priyanka. You can have any voltage across it. It depends on the remaining network. The relation will change. So please listen here. R plus delta R and R. Here what is the meaning of voltmeter? Very important point is here. Please comment. What is the internal resistance of the voltmeter? voltmeter का internal resistance क्या होता है भाई बताओ? Internal resistance of voltmeter. What is the internal resistance of the voltmeter? Comment. What is the internal resistance of voltmeter? Can you tell me? It is not 0, infinity. आप वोल्टेज मेजरमेंट में 0 कनेक्ट किया तो वायलेशन ऑफ केवीएल हो जाएगा भाई. वोल्टेज मेजरमेंट में इट शुड बी इंफिनिटी. ओके, इट शुड नॉट बी शॉर्ट सर्क्यूट. शॉर्ट सर्क्यूट है तो वोल्टेज कैसा मिलेगा आपको? ओके, व्हाट इज द इंटरनल रेजिस्टेंस ऑफ? दिस इज आइडियल. ओके, नॉट प्रैक्टिकल. आइडियल एमीटर ये तो 0 होता है. करंट, दैट्स व्हाई एमीटर तो सीरीज में कनेक्ट करेगा, सो टू डिटेक्ट द करंट. वोल्टमीटर तो पैरेलल में कनेक्ट करेगा. यू विल बी स्टडीइंग दिस बेसिक्स इन योर मेजरमेंट्स एंड ऑल आल्सो. नाउ प्लीज ट्राई टू अंडरस्टैंड द स्टेटमेंट ऑफ द क्वेश्चन. स्टेटमेंट ऑफ द क्वेश्चन में क्या बताया? मेरा पास 4 रेजिस्टर है, आर 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 प्लस डेल्टा आर. ठीक है, फाइन. नाउ व्हाट हैपेंस इज इफ ऑल आर आर्स, my meter will not detect any voltage because the bridge is balanced. Because of this delta R, ब्रिज को थोड़ा सा डिस्टर्बेंस आया. थोड़ा सा डिस्टर्बेंस आने के बाद क्या हो गया सर? यहीं पे आपको थोड़ा सा वोल्टेज आ रहा है. बट योर मीटर इज हैविंग ए रेजोल्यूशन ऑफ 0.1 मिलीवोल्ट्स. इसका मतलब क्या सर? योर मीटर कैन डिटेक्ट मिनिमम. व्हाट इज द मीनिंग ऑफ रेजोल्यूशन? इट इज द मिनिमम रीडिंग ऑफ द मीटर इज 0.1 millivolt. That is, if this disturbance is creating the voltage which is less than 0.1 millivolt, it cannot read. इससे ज्यादा दिया तो it will read. ठीक है, so minimum delta R कितना such that this voltmeter can read. मैं तो repeat कर रहा हूँ question. Because of this delta R, there is a disturbance in the circuit. You are getting some voltage here. That is measured with the help of voltmeter. But the voltmeter cannot read the reading less than 0.1 millivolt. So to get that 0.1 millivolt, what is the minimum value of delta R you should read? That is, what is the minimum delta R that can be detected by this meter? That is the minimum delta R that will create a minimum voltage of 0.1 millivolt. Okay, let's do it. So आप लोग आपका लैब में इसको यूज किया ना? Yes or no? वोल्टमीटर वाला. ओके, सो किसी भी टाइम पे ऐसा कर सकते, ट्राई करो. वोल्टेज मेज़र करने समय में ये वाला नॉब निकल के यहीं पे कनेक्ट करके मेज़र द वोल्टेज. क्या होता है देख लो. ओके, इमीडिएटली आपको लैब में फाइन लगेगा. मे बी यू माइट हैव डन. इट इज़ ए कॉमन मिस्टेक फॉर मोस्ट ऑफ द स्टूडेंट्स. सो कीप इट इन द एम्पियर मोड and measure the voltage. Then what happens? Because of the short circuit, you will get a huge current will be flowing through it. Then what happens it, because depending on the other side source there may be a violation of KVL, your fuse may go, all those things can happen. Because that's why for current and voltage separate knobs will be given. You need to change it when you measure the voltage and current. In your first year or second year, this is the most common mistake. By chance without changing it you might be used. Same thing, आइडियल वोल्टमीटर तो इनफाइनाइट इंपीडेंस होता है आइडियली, प्रैक्टिकल वोल्टमीटर में सम इट विल बी हैविंग वोल्टेज इज मेजर्ड इन पैरेलल, करंट इज मेजर्ड इन सीरीज. ओके, लेट्स डू द क्वेश्चन. नाउ दिस इज द क्वेश्चन. एग्जामिनर हैज गिवन आपका R इक्वल टू 1K, V इक्वल टू 2. नाउ आइडियल वोल्टमीटर दिया ना, रिप्लेस द वोल्टमीटर विथ ओपन सर्क्यूट, रिप्लेस द वोल्टमीटर विथ ओपन सर्क्यूट. I just replaced the voltmeter with a open circuit. Okay, just remove this branch. Fine. So after removing that branch, these two elements are in series. These two elements are in series. I want to measure this voltage and this voltage. And this is my voltage between AB. Just giving some names, that's all. So what is the voltmeter reading VAB? It is VA minus VB. Okay, what is VA, sir? V into this. What is that? R plus delta R by R plus delta R. डेल्टा R का मतलब क्या सर? डेल्टा टाइम्स R, लाइक 2 टाइम्स R, 0.1 टाइम्स R, ऐसा डेल्टा टाइम्स R. ठीक है, दिस इज वोल्टेज डिवीजन प्रिंसिपल बिकॉज द एलिमेंट्स आर इन सीरीज. वाई सीरीज? बिकॉज इट इज ओपन सर्क्यूट. ये दोनों में क्या होता है सर? V इंटू आर बाई आर प्लस आर. ठीक है, आपका VAB क्या होता है सर? आपको V पता है ना, 2 इंटू, आप R कॉमन ले लो, 1 प्लस डेल्टा बाई 1 प्लस डेल्टा 2 प्लस डेल्टा माइनस 2 इंटू 1 by 2. As per examiner, this should be greater than 0.1 millivolts. That is, it should be than 10 power minus 4. This is the required condition. Now solve this further. What is the unknown quantity? Find delta. And what is delta R? You get 2000 by 9999. That is the answer. That is the minimum value of delta R required. You calculate this delta, you get 2 by 9999. Okay, just to do this math part, remove, find a delta from this equation. Delta should be greater than or equal to this one. You will get it. ठीक है, ये पार्ट तो आप लोग घर पे करो, just simple math only. Okay, so the minimum value of the delta R that can be detected is 2000 by 9999. Good, Mamata. I also did it. Right. Chalo. Is it fine? Shall we go to the next question? This is how you deal with your voltmeter. Voltmeter is ideal voltmeter का internal impedance is infinity. Ideal voltage source का 0. Don't confuse. Yes, if the bridge is balanced, अगर delta R नहीं है तो it is 0 only. But because of the delta R only, this question came into picture. Okay? Gaurav? Chalo. So next question. Simplify the network between A and B. Simplify the network between A and B. Here, I want to give you one important point called as source transformation. Source transformation क्या होता है sir? Listen. Before doing this problem, let me give you source transformation के बारे में थोड़ा सा explanation. So, source transformation is generally used to convert voltage source into current source and vice versa. आपके पास ठीक है, जैसा सोर्स है तो यू कैन रिप्लेस दिस विथ ए if is equal to Vs by Rs or Vs equal to Is into Rs. This is the relation. We can prove it. Okay, please listen. If you have a voltage, practical voltage source, ideal may not possible. Practical voltage source can be replaced with a practical current source by using which concept? Source transformation. इट विल मेक योर एनालिसिस, बहुत आसान होता है आपका एनालिसिस, ठीक है। सोर्स ट्रांसफॉर्मेशन ऐसा करेगा, वोल्टेज सोर्स को करंट सोर्स जैसा कन्वर्ट करेगा, करंट सोर्स को वोल्टेज सोर्स जैसा कन्वर्ट करने के लिए प्रॉब्लम को सिंप्लीफाई करने समय में ऐसा यूज हो जाएगा। यू कैन रिप्लेस एनी वोल्टेज सोर्स विथ इट्स इक्विवेलेंट करंट एंड वाइस वर्सा। कैसा प्रूव करना सर? देखो, इसमें लोड कनेक्ट करो RL, इसमें लोड कनेक्ट करो RL, इसमें करंट कितना होता है सर? इसमें करंट कितना होता है सर? फर्स्ट केस में Vs बाई Rs प्लस RL, सेकेंड केस में करंट डिवीजन Is इंटू अपोजिट रेजिस्टेंस बाई टोटल रेजिस्टेंस। आपको दोनों नेटवर्क्स इक्वलेंट होना चाहिए तो क्या होना चाहिए सर? डिनोमिनेटर तो इक्वल है ना, ए न्यूमरेटर इक्वेट होना चाहिए। दैट इज योर Vs शुड बी रिप्लेस्ड बाई IsRs or Is should be replaced by Vs by Rs. Then both the circuits will work in the same way. That is, if you have a voltage source, you should replace with a current source of Vs by Rs with arrow upward from negative to positive. Similarly, you have a current source, you can replace with a voltage of Vs, which is equal to Is into Rs. It is not possible for ideal sources. For a dependent, it is possible, but don't disturb the variables of the dependent source. That is, see here. When we do the problems, I will show you that, okay? Without disturbing the variables, you can apply for dependent sources also. Anywhere, whenever you apply source transformation, please listen here. For example, okay, here you have a source, Vs. I am replacing this with current source of Vs by Rs. What is the current here sir? 0. What is the current here sir? 0. दोनों इक्वल है सर? है, बट इसमें थोड़ा सा ऑब्जर्वेशन किया तो एक डिफरेंस है दोनों फिगर में। कैन यू टेल मी व्हाट इज द डिफरेंस बिटवीन दीज टू फिगर्स? आर दे सेम और एनीथिंग डिफरेंट इज देयर? प्लीज टेल मी, प्लीज टेल मी, इज देयर सम डिफरेंस बिटवीन दीज टू फिगर्स? ये दोनों फिगर में कुछ डिफरेंस है तो आप लोग बताओ। प्लीज टेल मी एनी डिफरेंस इज देयर बिटवीन दीज टू फिगर्स? If nothing is specified, everything is ideal, Siddh. Okay. Yes. Very good. Who is that? Siddh. In this case, internally current चल रहा है ना, resistor is consuming the power. In this case, internally current is not flowing, so resistor is not consuming power. That is, आप source transformation apply करना चाहे तो करो, but internally they are not same. Only externally they will be same, but internal conditions will not be same for the source transformation. ठीक है सर, चलो, is it clear? Source transformation can be applied to find the current in the network. You can do it, no problem in it, but internally they are same, not externally. इस source transformation use करके let's have one shortcut. Suppose I have V series with R1 parallel with another resistance R2. You can replace this with VR2 by R1 plus R2 in series with R1 R2 by R1 plus R2. Okay, here one more shortcut. If R1 equal to R2, this will be simplified as V by 2 R by 2. This is the question, what is the equivalent of this network is? You apply source transformation here. what happens? You get V by R1 parallel with R1 parallel with R2. Now replace these two with a single resistor. इसके बाद एक और source transformation अप्लाई करो, ये आंसर आएगा. ठीक है, ये तो आपका V by R1 R2 by R1 plus R2, इसको सोर्स ट्रांसफॉर्मेशन अप्लाई करो, ये वाला फिगर आएगा. दैट इज किसी भी नेटवर्क पे आपके पास एक वोल्टेज सोर्स, इसका सीरीज में एक रेजिस्टर, पैरेलल में एक और रेजिस्टर मिलेंगे, तो इफ यू गेट ए वोल्टेज सोर्स सीरीज विद रेजिस्टेंस पैरेलल विद अनदर रेजिस्टेंस, then you can replace with a V into R2 by R1 plus R2 series with R1 R2 by R1 plus R2. If R1 R2 equal, then it is very simple shortcut you can write. So let's do the question based on this. It is a IES question given in the 2012 IES conventional question paper. So let's simplify this network between AB using our method. Listen here. You have a voltage source series with a resistance, parallel with a resistance. What is the shortcut? V into R2 upon R1 plus R2 series with R1 R2 by R1 plus R2 is the formula. They are not parallel, but after source transformation they look like that. Okay, so this is the equivalent. This is 20. Then here current source parallel with a resistance. What is the source transformation? Voltage source of V equal to I into R, arrow direction negative to positive, series with a resistance 2. Next, बाकी नेटवर्क एज इट इज ले लो. ये तो 4 दिया एग्जामिनर. ठीक है, नाउ लिसन केयरफुली. कैन आई रिप्लेस 16 एंड 20 दोनों ऐड कर सकते, पोलैरिटी सेम है ना, 36. कुछ डाउट है तो केवी ऑल्सो चेक करो. इट इज हाउ मच? दिस इज सॉरी 8 ohms na resistance. Okay, so what is your resistance? 8 plus 4 12, and again you have 4, this is 4 and 2, right? So I am writing here voltage figure can be simplified as a simple voltage source series with a resistance. That is the advantage of source transformation. It will make your analysis easy. हमारा shortcut नहीं use किया तो first you should apply source transformation for this, then you should take 20 parallel with 5, then again source transformation. We skipped those 3 steps with a single step like this. Okay, so this is how you can apply source transformation concept to convert the voltage source into current or current into voltage. It is applicable only for practical, not for ideal, and it is applicable for dependent or independent also, but the variable of the source should not be disturbed. ठीक है? Okay, 7 and 7. Okay, let's move. So read these points. Source transformation is a simplification technique which eliminates the extra nodes present in the network. By using the source transformation, a practical voltage source can be replaced with its equivalent practical and vice versa. You cannot apply source transformation to the ideal sources. We can apply source transformation to the dependent sources if the control variable is outside the loop of transformation. Okay, we can apply the source transformation to the dependent also if the control variable is outside the where you are applying the transformation. Okay, let's do the next question. Just a minute. Okay, let's give a try for this question. Okay, so let me give you the statement also. Listen here, the statement of the question is if an ideal current source connected between A comma B, अगर एक आइडियल करंट सोर्स ए और बी का बीच में कनेक्ट किया तो फाइंड द रीडिंग ऑफ द एमीटर. सो आइडियल एमीटर find the reading of the ammeter. Please do it and tell me the answer. Find the reading of the ammeter. Just give a try and tell me the answer. अगर एक आइडियल एमीटर कनेक्ट किया तो ए और बी का बीच में, व्हाट इज द रीडिंग ऑफ द एमीटर इज द क्वेश्चन. No. Try it. Internal impedance of the ideal ammeter क्या होता है सर? ammeter current source नहीं, ammeter का internal impedance 0 होता है. So let me replace this with a short circuit here. This is the current you need to find. Okay. Now I am giving you my shortcut. When this is short, no current will flow through this branch because parallel में short है तो पूरा current short से चलेगा. So now see here, what is our shortcut to do this problem? You can do by node analysis, no doubt. But shortcut is voltage source series with resistance, parallel with resistance. What is our source transformation technique? If R1, R2 same, you can replace with what? 9.6 by 2, that is 4.8. Series with 6, parallel with 6 is how much? 3. Remaining network as it is ले लो. 6 and 6 between A and B. Now connect the short circuit between A and B. Find the current I. What is the I, sir? 4.8 by 3 plus 6, 0.53. Bas. Okay, who got it? Very good, Gaurav. Right answer. It's a simple question. You should replace ideal ammeter ka internal impedance is 0. Replace this with a short circuit. Then you can neglect this. Voltage source series with a resistance, parallel with a resistance. If R1, R2 equal, our shortcut is V by 2 series with R by 2 is the simplest equivalent after source transformation. Chalo, next question. Okay. Just a minute, guys. Okay. So let's discuss the next part of your discussion, that is Telegan's theorem. In the basics, the next one we need to discuss is Telegan's theorem. So the next part we have is Telegan's theorem. ठीक है, टेलीगन्स थ्योरम क्या कहते हैं? किसी भी नेटवर्क ले लो, यू टेक एनी नेटवर्क, algebraic sum of powers at any instant should be equal to 0. इसका मतलब क्या सर? पावर डिलीवर्ड इन द नेटवर्क बाय सम एलिमेंट्स, किसी भी एलिमेंट से पावर जो डिलीवर होता है ना, दैट इज ऑलवेज इक्वल टू द पावर एब्जॉर्ब्ड बाय द रिमाइनिंग एलिमेंट. बाकी एलिमेंट्स का पावर एब्जॉर्ब्ड एंड पावर डिलीवर्ड किसी भी नेटवर्क में सेम होना चाहिए. दैट इज लॉ ऑफ कंजर्वेशन ऑफ पावर. इट इज इंडिपेंडेंट ऑफ नेचर ऑफ एलिमेंट्स. सी हियर, पावर डिलीवर कैसा होता है सर? सोर्स है तो पावर कैन बी डिलीवर्ड और एब्जॉर्ब्ड. रेसिस्टर है तो हमेशा पावर तो एब्जॉर्ब खाता है ना, सो पावर एब्जॉर्ब्ड ओनली. सो हाउ टू फाइंड डिलीवर और एब्जॉर्बिंग सर? बेस्ड ऑन द करंट डायरेक्शन. अगर आपका करंट डायरेक्शन पॉजिटिव से नेगेटिव है तो द एलिमेंट तो अब्सॉर्ब होता है, करंट डायरेक्शन नेगेटिव से पॉजिटिव है तो दैट पर्टिकुलर एलिमेंट विल बी डिलीवरिंग द पावर. लेट्स सी दोस पॉइंट्स. According to Teligans, in any arbitrary network that is independent of nature of elements, algebraic sum of powers at any instant is equal to 0. Power delivered by some elements in the network equal to the power absorbed by the remaining elements in the network. If the current enters from positive, leaves from negative, then the element is absorbing the power. If the current is entering from negative, leaving from positive, then the particular element is delivering the power. Okay. सोर्स में डिलीवर और में एब्जॉर्ब, बट द पैसिव एलिमेंट्स लाइक रेजिस्टर्स हमेशा क्या करेगा सर? एब्जॉर्ब करेगा. एक इंपॉर्टेंट पॉइंट क्या, व्हाइल वेरीफाइंग इंटेलिजेंस थ्योरम डू नॉट डिस्टर्ब द रेगुलर ओरिजिनल नेटवर्क. क्योंकि आप सोर्स ट्रांसफॉर्मेशन अप्लाई किया तो इंटरनल पावर रिलेशंस विल वेरी, विच विल नॉट गिव यू क्लियर पिक्चर अबाउट डिलीवरिंग एंड एब्जॉर्बिंग प्रॉपरली. ठीक है, एक क्वेश्चन करेगा. सो ये वाला क्वेश्चन क्या है सर? स्टेटमेंट क्या होता है इसके? वेरीफाई Teligans theorem. ठीक है, इस वाला फिगर पे टेलीगन्स थ्योरम वेरीफाई कर सकते हैं. लेट्स डू इट. सी एग्जामिनर ऐसा फिगर दिया, पोलैरिटीज कुछ नहीं दिया, डायरेक्शन हम वी शुड फाइंड इट. सी देखो, ये करंट ऐसा चलेगा. हमेशा केसीएल चाचा पे डिपेंड करो, केसीएल चाचा हमको हेल्प करेगा. केसीएल और केवीएल पैरेलल पे क्या होता है सर? वोल्टेज सेम होता है, सेम पोलैरिटी लेना चाहिए. अभी इसका करंट कितना होता है सर? 10/10 1 एम्पियर. नाउ इसको यूज करके आप बताओ, ये करंट 2 एम्पियर एंटर हो रहा है, ये तो चल रहा है 1 एम्पियर, देन बाकी 1 एम्पियर शुड लीव दिस. सी हियर, if it is a resistor, we can blindly take current direction is always positive to negative, but for the source you cannot find the current direction. इसलिए क्या करना, बाकी currents calculate करके इसका current direction निकलेगा. That is, we find the current in these two branches. Based on that, we find this current. Entering is 2, leaving is 1. Then it should be 1. Similarly, this is 1 ampere. This is 2, so 4 volts. Now I want to know this voltage because I don't know the polarity of the current source voltage. It can be reverse also. No one knows. So क्या करेगा? एक बार KVL अप्लाई करके कैलकुलेट करेगा. Your answer can be positive negative क्योंकि इसका polarity can be reverse also. आप लोग KVL अप्लाई करो. नेगेटिव से पॉजिटिव V2A, पॉजिटिव से नेगेटिव -4, पॉजिटिव से नेगेटिव -10. कितना होता है सर? V2A 14. ठीक है, हमारा पोलैरिटी जो एज्यूम किया ये तो सही है. द पोलैरिटी आई हैव एज्यूम्ड इज करेक्ट. ठीक है, मेरा एजम्पशन तो करेक्ट है. अभी आप बताना चाहिए कौन सा एलिमेंट एब्जॉर्ब हो रहा है, कौन सा एलिमेंट डिलीवर हो रहा है. ठीक है सर, एरो डायरेक्शन पॉजिटिव से नेगेटिव है तो ये वाला कंपोनेंट तो एब्जॉर्ब कर रहा है. ये डायरेक्शन कैसा सर? नेगेटिव से पॉजिटिव. आप बताओ, नेगेटिव से पॉजिटिव है तो आपका एलिमेंट क्या कर रहा है सर? ये तो काना दे रहा है, ये लोग काना का रहे हैं. बस हम क्या प्रूव करना? पावर डिलीवर्ड इज इक्वल टू पावर एब्सॉर्ब्ड. 2 एम्पियर कितना पावर दे रहा है भाई? वोल्टेज 14 करंट 2 28. पावर एब्सॉर्ब्ड कितना भाई? व्हाट इज द पावर एब्सॉर्ब्ड बाय द रेजिस्टर? 2 ओम रेजिस्टर कितना एब्सॉर्ब कर रहा है सर? वोल्टेज इनटू करंट. नेक्स्ट 10 ohm resistor, voltage into current. 10 volt source, voltage source है ना, इसका voltage कितना 10, करंट कितना 1, पूरा 28 वाट. ठीक है, पावर डिलीवरिंग किया, एब्जॉर्बिंग किया, दोनों इक्वल हो गया. वी हैव प्रूव्ड दैट द पावर डिलीवर्ड इज इक्वल टू पावर एब्सॉर्ब्ड. ठीक है, कुछ डाउट है तो बताओ. थैंक यू महेश. नहीं है तो मैं आगे चलेगा नेक्स्ट वाला क्वेश्चन पे. टेल मी एनी क्वेरी. नहीं है तो वी कैन मूव फर्दर. गुड. राइट, ये तो प्रीवियस गेट क्वेश्चन है, गेट 2014 पे दिया. Let's try to solve it. A part of a network is shown in the figure. Determine the power absorbed by three elements. Okay. Power absorbed by the तीन elements दिया ना एग्जामिनर. ये तो पूरा नेटवर्क नहीं, ये तो पार्ट ऑफ ए नेटवर्क. ठीक है, ये एग्जामिनर दिया, ये तीनों एलिमेंट्स, ये पूरा नेटवर्क नहीं, कंप्लीट नेटवर्क नहीं है, ये तो नेटवर्क का पार्ट है. ये तीनों एलिमेंट्स कितना पावर एब्जॉर्ब कर रहा है. चलो लेट्स डू इट. ओके, सी हियर, एग्जामिनर ने दिया ये वाला करंट 10 एम्पियर, ये तो 8 एम्पियर दिया. फिर इसका करंट कितना होता है सर? इसमें थोड़ा सा प्रिंटिंग मिस्टेक है. दिस इज द फिगर. ठीक है, चलो ये तो 10, ये तो 8 है, तो ये 2 होना चाहिए. नाउ इसका डायरेक्शन नेगेटिव से पॉजिटिव, डिलीवरिंग. ये भी नेगेटिव से पॉजिटिव, डिलीवरिंग. ये तो पॉजिटिव टू नेगेटिव, एब्जॉर्बिंग. ठीक है, देन व्हाट इज द पावर एब्जॉर्ब्ड बाय तीनों एलिमेंट्स? रीड द क्वेश्चन. इज इक्वल टू 10 into 100 माइनस, ये दोनों डिलीवरिंग ना, एब्जॉर्बिंग क्या होता है सर? माइनस 15 into 2 माइनस 8 into 80. ये कितना होता है सर? 330 वाट्स. ठीक है, दैट इज हियर. इनको ये दैट इज पावर डिलीवर्ड इज नॉट इक्वल टू पावर एब्जॉर्ब्ड हियर, क्योंकि ये पूरा नेटवर्क नहीं, पार्ट ऑफ द नेटवर्क. हाउ मच इट इज डिलीवरिंग इज 1000. Sorry, how much it is absorbing is 1000, delivering kitna 670. So if you subtract that, that is the net power absorbed by these three elements from the remaining network. It requires 1000, in that 670 is given by these two, remaining 330 is the net power absorbed by the three elements from the remaining part of the network. ठीक है, चलो right, very good. Next, just a minute. Yes, read this question, guys. It's a GATE 2009 question. It is given in GATE 2009. Okay, so give a try. Power is conserved, my dear Boomchick. I don't, Debaran. Okay, power delivered is equal to power absorbed. Yes, correct, Debaran, because it is a part of a network, power delivered is not equal to power absorbed. Deeptapal, right now I don't have the info about it. ठीक है, चलो. If the network shown in the figure 60 volts is absorbing, ये तो गेट 2009 में 1 मार्क के दिया, बहुत easy question है. Examiner has given it is absorbing. Absorbing में करंट डायरेक्शन कैसा होता है सर? पॉजिटिव से नेगेटिव और नेगेटिव से पॉजिटिव. कमेंट करो. पॉजिटिव से नेगेटिव होता है और नेगेटिव से पॉजिटिव होता है सर? पॉजिटिव से नेगेटिव. ठीक है, ये आपका Ix. चलो, नाउ that is your Ix is assumed correct only because it is absorbing. So by KCL 12 entering is equal to leaving. आपको पता है Ix is a positive value because since it is absorbing. 60 वोल्ट सोर्स तो एब्जॉर्व कर रहा है ना, इसका मतलब करंट कंपलसरी पॉजिटिव से नेगेटिव ही फ्लो करना चाहिए, ये तो कंपलसरी पॉजिटिव वैल्यू होता है, नेगेटिव का मतलब रिवर्स डायरेक्शन, तो नॉट पॉसिबल। इसका मतलब Ix पॉजिटिव है तो आपका I क्या होना चाहिए सर, लेस देन 12। आपका सारे ऑप्शंस देख लो, एक ही ऑप्शन सेटिस्फाई करेगा लेस देन 12 वाला कंडीशन, कौन सा ऑप्शन, 9 ओनली। सर आपको डाउट आएगा, सर दो ऑप्शंस लेस देन 12 आएंगे तो MSQ पे दे सकते हैं, because multiple select में which of the following can be, yes you cannot find the exact value here, any value less than 12 can be your answer, ठीक है। वेरी गुड वेरी गुड, चलो ये भी हो गया 2014 वाला क्वेश्चन। नेक्स्ट लेट्स मूव टू द नेक्स्ट टॉपिक, आई मीन नेक्स्ट कॉन्सेप्ट। Okay, read this question guys, just give a reading, let's do it। ये भी previous gate question है। Figure shows the current flowing through the capacitor of 1 microfarad, find the charge acquired by the capacitor up to how much time, 5 microseconds, 5 microseconds तक what is the charge acquired by the capacitor। एग्जामिनर ने करंट दिया, एग्जामिनर को क्या चाहिए, चार्ज चाहिए। लेट अस डू इट, लेट्स ट्राई, प्लीज केयरफुली। व्हाट इज द करंट I of t, dq by dt। q क्या होता है सर, इंटीग्रेशन ऑफ I of t dt, इंटीग्रेशन नथिंग बट एरिया। एग्जामिनर ने करंट दिया, चार्ज चाहिए, जस्ट फाइंड द एरिया हियर। What is the area of this up to 5, that will give you your answer, ठीक है। 5 तक एरिया निकालो, ठीक है। ये तो एक ट्रायंगल, एक रेक्टेंगल भी है, ठीक है। और ये भी एक ट्रायंगल, एक ट्रायंगल, ठीक है सर। आपका Q क्या होता है सर, ट्रायंगल क्या है सर, हाफ इंटू बेस 3 हाइट 5, फिर दिस वन 3 to 5 2 into 3, फिर ए वाला 1 into 2, हाफ इंटू बेस इंटू हाइट, फिर ये वाला हाफ इंटू बेस इंटू हाइट। कैलकुलेट करो, आपका आंसर आएगा 15। टाइम इज इन माइक्रो सेकेंड्स, सो आपका चार्ज माइक्रो कूलम्स होता है, ठीक है, राइट। चलो नेक्स्ट क्वेश्चन, दिस इज अ सिंपल क्वेश्चन, दैट फाइंड q इज गिवन, यू नीड टू फाइंड q इज इक्वल टू इंटीग्रेशन ऑफ I dt। रीड दिस क्वेश्चन। A fully charged mobile battery is good for 10 minutes walk time, नहीं talk time, थोड़ा सा typing error, talk time। During this 10 minutes it delivers a constant current of 2 amperes and voltage decrease linearly to 12 to 10 from 12 as shown in the figure। Find the energy delivered by the battery in joules, Jovis 9, ठीक है। आप लोग ट्राई करके आंसर बताओ, प्लीज गिव ए ट्राई। Give a try. Alessandro, you can see the crash course on digital circuits playlist. There you go for sequential circuits, there you can find it. Option B, there I, option D, there I. Different people are giving different answers. Okay, let's do it. Firstly, what is the formula for energy? Integration of 0 to t power p dt. It can be given as 0 to t voltage V into current I dt. Okay, so this is your energy ka equation. So examiner has given E equal to integration of 0 to t. Okay, voltage is we don't know. Voltage current is constant into V. You can write the equation of the voltage or you can find the area. So this is given by examiner. Here, what is T? Most of you have taken 10, then it is wrong. You should take 600. Time should be converted into seconds. That is important here because the energy is in joules. So here time is in minutes. Convert into joules. Then you can do it easily. It will be equal to 2 into what is the area of this? 600 into 10 plus half into base into height. Calculate, you get 13,200 joules. So be careful, this is not the right answer. Okay, 10 is not the right answer. Minutes may 10, you should take seconds. It is 600. Okay, so here current is constant, voltage we need to apply. Okay, next. Okay, let me give you one question here. Sorry, one information. For periodic signals, we define average power is given by energy dissipated in one time period by time period. That can be written as integration of 0 to t. Energy is always integration of power. Power for one time period. That is, it can be written as I square into R dt by t, or you can write it as V square by R by t into dt. This can be written as, we discussed that in your next topic AC analysis, IRMS whole square into R, or this can be written as VRMS whole square by R. Okay. So when periodic signals are given for finding average power, we should use this. For example, you have this kind of signal. What is this signal? We call ramp signal. Suppose this current I of t and R equal to 10 is given by examiner. For example, calculate average power is your question. What is the answer in this case? Integration of 0 to time period, one time period, I square. I is here ramp signal of 10t. Okay, AT by t we call 10t whole square into R dt. This will give you 1000 t square ka integration t cube by 3. That is 1000 by 3. Here, what is the time period is 1. What is the signal? AT by t. This you study in your signals also. Okay, this is how you calculate the average power. This basic I will use later. Okay, what is the meaning of RMS? Everything we discuss it in the AC analysis. Now let's use that and solve this question. Okay, so read this question. Okay, guys, in the figure shown in the figure, the current through the inductor is inductor of resistance 1 ohm, inductance 2 Henry, okay, is given below. What is the energy absorbed by the inductor? In the question is up to 4 seconds. It is given in GATE 2003. Repeat if it is a voltage across a capacitor. This we can try later. First, let's do it. Ideally, inductor will have zero resistance, but practically its loss is represented with internal resistance in series. Here examiner has given L is 2 Henry, R is 1 ohm. Okay, so please listen here. What is this signal? It is called ramp signal of 3T. This is a constant signal of 6. Okay, now listen here. What is the energy total is taken by two elements, resistor or inductor? Examiner question is energy absorbed. Okay, two people will take it, inductor and resistor. What is the energy of the resistor formula? Integration of 0 to t current square into R dt. Okay, so that is integration of 0 to t I square. What is I square? T is up to 2 you take. Examiner ko up to 4 chahiye na. Up to 2 it is 3t whole square into R plus 2 say 4. What is its current? Constant na. It is constant from 2 to 4. It is 6 square into 1 dt. This will be 9t cube by 3. This will be 36t. Calculate, you will get the limits apply kiya to you will get 24 plus 72. It will be equal to 96 joules. This is energy taken by only resistor part of the inductor. If you want to find the energy taken by the inductor part, then what to do? 1 minute. Now, listen here. What is the energy taken by the inductor part is integration of 0 to t current into voltage V, that is L di by dt into dt. Then integration of 0 to 2, current is how much? It is 3t. L is 2. What is d by dt of 3t? 3 into dt. From 2 to 4, what is the current, sir? 2 to 4, what is the current, sir? 2 to 4 current क्या है, sir? 2 to 4 current क्या है? Constant 6 into L into d by dt of 6 कितना होता है, sir? 0. So here it is 3 to 6, 6 3 is 18 t square by 2 plus 0. This will give you 36 joules. Total energy is equal to 96 plus 36. Okay, 132 joules. Fine, sir. ठीक है, sir. ध्यान से सुनो, sir. 2 से 4, okay, since current I equal to constant energy in the inductor from 2 to 4 कितना? 0. इसका मतलब क्या, sir? Whenever current through the inductor is a constant, no variability is there, d by dt is 0. During that interval, inductor will not store any new energy, but it will maintain the previous energy as it is. So please listen here, another point I want to say. Instead of doing this much, you can also do like this. Energy in the inductor is equal to half L I square of t. So energy in the inductor from 0 to t chahiye to, that is 0 to 4 chahiye to, you can do it like this. EL of 4 minus EL of 0. That is energy in the inductor half L What is the value at time t equal to 4? Current value 6 square minus half L. What is the initial value? 0. This will give you also same answer without doing this much. That is, if you know the inductor current at any instant, you can find the energy by using the formula half Li square. Okay, let me give you those formulas. 1 minute. Okay, please read these points. The energy stored in the inductor at any instant of time depends on current at that instant only. That is the energy stored from the minus infinity to that particular instant. What is the formula? Half Li square. Okay, half Li square. Is it clear? And what is the point I told? Whenever the current through the inductor is constant from x to x1, t1 to t2, during that interval, inductor will not store any further energy. Okay? So here, क्या हो गया? पूरा गया. Okay? So don't worry, I will write again. I'll quickly write it. Right. Next. So this is one point, and another point is whenever the current through the inductor is constant, किसी भी time interval पे inductor का current constant है तो उस समय पे inductor will not store any energy. But resistor हमेशा energy खाएगा. Whether it is positive, negative current doesn't matter. हमेशा resistor will absorb the energy. Is it clear? So see here the same question, small change. In the above case, what is the energy stored in the inductor? Up to 6 seconds. See here. This is the figure given by examiner. Na? Up to 6 seconds, what is the energy stored by the inductor? Read it. Read the question carefully and answer it. ध्यान से पढ़ के आंसर दे दो. In the above case, energy stored by the inductor of resistance 1 ohm inductance up to 6 seconds. इतना टाइम क्यों ले रहा है? Don't calculate. It is equal to E is equal to 36 joules only. Don't calculate the resistor energy because examiner asked stored. Only inductor can store. Resistor part cannot store. If absorbed is asked, then we should take EL and ER. You understand na? This is the energy stored even up to infinity also. क्यों सर? क्योंकि इसके बाद करंट कांस्टेंट हो गया, एनर्जी विल नॉट बी स्टोर्ड बाय द इंडक्टर. सो मैं तो कंक्लूजन्स दे रहा हूँ, ध्यान से सुनो. Whenever current in the inductor is constant, it will not store any energy during that time. It will store when there is a slope only. But for resistor, those rules are not applicable. Whenever, if you want stored energy means you should calculate only inductor because resistor will never store any energy. Okay. And another thing, what is that? Whenever what we call, if you want inductor energy at any point, you can use the formula half La square. That will give you the energy stored in the inductor. So let's go. 1 minute. So guys, listen here. For example, this kind of waveform is there. Okay. What is the inductor? L is equal to 2 Henry. Just for understanding in a better way. What is the energy from 2 to 5? What is the answer? आप लोग बताओ. What is the energy in the inductor from 2 to 5? What is the energy in the inductor from 2 to 5? It is simple formula. EL of 5 minus EL of 0. Sorry, EL of 2. 0 because it is the same. So whatever happens in between doesn't matter. It only depends on these two values. For example, if I ask you energy in the inductor from 0 to 4, what is the answer in this case? EL of 4 minus EL of 0. What is EL of 4? Half L I square. At time t equal to 4, what is its value? 4 square minus half L I square of time t equal to 0. In this case, initial energy is not 0. This is how you do the calculations. For inductor, during this period, it will charge. During this period, it will discharge. पॉजिटिव स्लोप में चार्ज हो जाएगा, नेगेटिव स्लोप में डिस्चार्ज हो जाएगा. इस समय पे नाइदर नॉर. ठीक है. बट रेसिस्टर ऐसा नहीं. Here it will take, here it will give, here it will be neither nor. But resistor, every time it will eat. Whether it is positive slope, negative slope or constant doesn't matter. Because what is the resistor power? I square into R. It does not depend on the slope. Integration of I square into R. If you have some current, whether it is positive, negative, doesn't matter. Resistor always eats the energy. It will dissipate the energy in the form of heat. Here it will store the energy. This is just a basic I want to give you for your clarity. कुछ doubts है तो बताओ. You need to have d by dt for storing the energy. D by dt is required, Gaurav. कुछ doubts है तो बताओ. For inductor, loss is represented in series. For capacitor, loss is represented in parallel. Inductor में energy is half La square. Capacitor energy is half Cv square. Okay. Okay. Who will store the energy? Only inductor will store the energy. How much energy is stored at any instant is half La square. If you want energy at an instant, half La square of t. If the energy between two instants, final minus initial. Very good, very good. चलो next. ये वाला क्वेश्चन देख लो. मेरे पास दो नेटवर्क है सर. दोनों नेटवर्क में ऐसा एग्जामिनर इंफॉर्मेशन दिया. दिस इज 35 वोल्ट्स एंड एग्जामिनर ये भी दिया. यू नीड टू फाइंड द करंट. हाउ टू डू दिस क्वेश्चन? KCL अप्लाई करो. 20/2 क्या होता है सर? 10 एम्पियर. 35/7 क्या होता है सर? 5 एम्पियर. Current entering should be equal to current leaving. It's a simple KCL question recently given. Okay. दो branches का voltages दिया. We find the current. That is current KCL. So any network में KCL must be satisfied. Right. I want to give you some theory and two problems, then we can end the class. Tomorrow I will discuss the resistance of the cube, then your basics are finished. Then I will go for the maybe AC analysis. I will be going to start tomorrow morning session. Evening we will continue with the two-port networks. See here, if you have a single capacitor, I can show you by something, right? You have a capacitor like this. Okay, this is one plate, this is one plate. In between these two plates, you have a dielectric material. So I assume like this. Okay, this is the dielectric material between two plates. Okay, so please see here, between two plates, if I keep the dielectric material, Then what is the capacitance formula? Epsilon A by D. What is the epsilon, sir? It is the permittivity E naught into ER. What is the area? Area of the plate is this length into its backside width. This length into backside my width. You are seeing only two dimensional. This length into width will give you area of the plate, and the distance between two plates, whatever the distance between two plates will give you the D. Epsilon A by D is the area of the capacitance. If the capacitor is made with a single dielectric, you can use this formula directly. अगर multiple dielectrics से किया तो you should take them in series. 3 बार आया क्वेश्चन इससे, जान से सुनो. 2014-15 पे 3 times this question appeared, this model question. So if your capacitor is made with 2 dielectrics, one in the top, one in the bottom, or the distance is divided into different dielectrics, E1 and E2, you can replace based on the electric field distribution into 2 series capacitors. You study in EMTL also same topic, C1 and C2, where C1 is epsilon 1, area same hota hai, distance D1. C2 is epsilon 2, again area same hota hai, distance D2. Okay, fine. Next, this is the another case. Okay, so here earlier you observe the distance here like this. If you have top part is 1 dielectric, bottom part is 1 dielectric. Okay, top part 1 dielectric, bottom is 1 dielectric. That is this one distance. Another part is left side 1 dielectric, right side 1 dielectric. This part is 1 dielectric, this part is another dielectric. That is length is divided into parts. You can replace this with 2 parallel capacitors, where C1 equal to epsilon 1, length is changed na, area is A1 by distance D. Here length changed na, area A2 by distance D. You can equate C1 by C2 like this. Okay, E1 is equal to free space E naught into relative permittivity. This material will define that. Okay, this is the capacitors with in 2 dielectrics. Okay. Let's go. Where it will violate in the last problem? Show me. There is no question of KVL here. Here, please listen. KVL is not violated. This remaining part you don't know, na? Here you have some voltages. Okay, KVL never be violated. Here, don't take all of them in parallel. Without knowing these 2 nodes, you cannot say these are in parallel. Okay, Mamata. Right, let's move. So let's try a question based on this. गेट 2013 पे एक क्वेश्चन दिया 4 मार्क के लिए. Okay, read the question, guys. Just read the question. I will give you the, I will explain the question. The network shown in the figure, the breakdown voltage of the capacitor C1 कितना 2 वोल्ट दिया, C2 कितना 5 वोल्ट दिया, and C3 कितना 10. Wait, मेरा पास 3 कैपेसिटर है. अगर इंडिविजुअली एक एक कैपेसिटर ले लिया तो इसका व्हाट इज दैट ब्रेकडाउन वोल्टेज कितना होता है 2, 5 और 10. Then what is the condition is determine the maximum safe. Individually you can apply up to 10 here, up to 2 here, up to 5 here. But ऐसा कनेक्ट किया तो what is the maximum voltage you can apply. आप लोग ट्राई करना चाहिए तो ट्राई करो. फर्स्ट क्वेश्चन, what is the maximum safe voltage you can apply. Okay, let me do it. So see here, if you take this as V1, this as V2, this as V3. Suppose here by voltage division principle V1 by V2 equal to capacitor na 1 by C1 by 1 by C2. It will give you C2 by C1 because V1 by V2 equal to Z1 by Z2 is the formula for series connection. Okay. So here C1 is less than C2. Compulsory V1 will be more than V2 because they are inversely related here. So simple understanding V1 हमेशा V2 से ज़्यादा होता है इस वाला नेटवर्क पे. मैंने शुरू करेगा इसमें 10 से. Here 10 I can take ना, I take 10 for example. Then what is the problem? एक वोल्टेज मोर देन 5 होता है, एक वोल्टेज लेस देन 5 होता है. दोनों में कौन ज़्यादा है सर? V1 ज़्यादा है. सो V1 मोर देन 5 होता है सर, चलेगा सर, ये तो काम नहीं करेगा सर. सो 10 कैनॉट बी टेकन, रूल आउट. नेक्स्ट सर, नहीं सर एक काम करो, यहीं पे 5 ले लो, V2 को 5 ले लो, V3 को 10 है तो नहीं, ऑल आर नॉट हैप्पी, ऑल शुड बी हैप्पी. मैं यहीं पे 5 देता हूँ सर, सभी हैप्पी आर नॉट चेक इट सर. इसमें 5 दिया तो क्या होता है सर? V2 5 है तो हमेशा V1 V2 से ज़्यादा होता है. V2 पे 5 ले लिया तो V1 V2 से ज़्यादा, 5 से ज़्यादा हुआ तो अगेन V1 C1 तो चलेगा. सो इट इज़ नॉट सेफ. सो क्या करना सर? शुरू करो यहीं पे 2 लेके, यहीं पे 2 ले लो. दैट इज यू टेक V1 इक्वल टू 2. नाउ व्हाट हैपेंस सर? व्हाट इज योर V2? V2 इज इक्वल टू V1 C1 by C2. That is 2 into 2 by 5, 0.8. Then what is your V3? V1 plus V2. That is 2.8. ठीक है सर. Then what is that? Here you should apply 2.8. Then आपको यहीं पे 2 आएगा, यहीं पे 0.8 आएगा, सभी सेफ होता है. इससे ज़्यादा क्या होता है सर? ये दोनों हैप्पी बट ये तो सेटिस्फाई नहीं हो जाएंगे क्योंकि इसका वोल्टेज 2 से ज़्यादा नहीं करना चाहिए. सो इट इज़ नॉट एवरी टाइम सेम वे. यू शुड चेक विच केस इज सेफ फॉर ऑल द 3. अगर एग्जामिनर ऐसा दिया, इसमें 5 तक दे सकते, इसमें 2 तक दे सकते, ऐसा दिया तो देन यू कैन अप्लाई 7 volts. इट डिपेंड्स ऑन द क्वेश्चन. एवरी क्वेश्चन रिक्वायर्स डिफरेंट वे टू सॉल्व इट. If the above, second question, read it and tell me the answer. अगर if the above safe voltage is applied, determine the charge stored by the combination. ये वाला वोल्टेज अप्लाई किया तो कितना चार्ज स्टोर करेगा वो पूरा तीनों एलिमेंट्स, तीनों एलिमेंट्स कितना स्टोर करेगा. सो आप लोग कौन 5 टाइप किया? 5 में हियर यू गेट समथिंग, हियर यू गेट समथिंग, ऐसा माइंड पे है तो देख लो. हमेशा V1 V2 से ज़्यादा होता है क्योंकि C1 लेस दैन C2. इफ यू अप्लाई 5 ऑल्सो, 5 by 2 हाउ मच? 2.5 से ये ज़्यादा होता है, इट विल बी गॉन. 32 coulombs. Let's do it. What is the energy here? Okay, Q equal to, what is the question? Q equal to C equivalent into V. C equivalent कितना सर? सीरीज में है तो 2 into 5 by 2 plus 5. पैरेलल में है तो add into पूरा वोल्टेज 2.8. That will give you 4 plus 28. Answer 32 coulomb. सर मुझको ये डाउट आया. Can I take Q equal to 2 into 2 plus 5 into 0.8 plus 10 into 2.8? ऐसा ले सकते क्या सर? 4 28 36 होता है ना? नहीं, गलत आंसर है. क्यों गलत आंसर सर? लिसन हियर. सीरीज में चार्ज हमेशा सेम होता है, हम डबल काउंट मत करना चाहिए. अगर 2 रेजिस्टर है तो एक में 4 एम्पियर चलेगा तो दोनों सीरीज में है तो दोनों रेजिस्टर में भी 4 चलेगा. इट डजेंट मेक करंट इक्वल टू 8 एम्पियर ना. करंट सीरीज में हमेशा सेम होता है. यू शुड नॉट काउंट इट 2 टाइम्स. सिमिलरली हमारा सीरीज में चार्ज सेम होता है, ऐसा इंडिविजुअली कैलकुलेट मत करना. क्या करना? C इक्वलेंट इंटू V करना चाहिए. ओके, लेट्स गो. लास्ट क्वेश्चन फॉर टुडेज क्लास. दिस इज अ गेट 2015 का क्वेश्चन, लेट्स डू इट। राइट, लास्ट क्वेश्चन फॉर टुडेज क्लास, लेट्स कंप्लीट दिस क्वेश्चन एंड वी कैन एंड द सेशन। बाकी तो पूरा आपका बेसिक्स तो हो गया, एक ही टॉपिक बचा क्या, इक्विवेलेंट व्हाट इज द रेजिस्टेंस ऑफ द क्यूब, वो भी डिस्कस करेगा। ठीक है, चलो लेट्स डू दिस। A capacitor is partially filled with a glass dielectric as shown in the figure. If the dielectric of the air is 30 kilovolt per centimeter, ठीक है, glass is 300 kilovolt per centimeter, determine the breakdown voltage of the capacitor। मैं रिपीट करेगा क्वेश्चन। मेरा कैपेसिटर है, ये तो फिल किया ग्लास डाइलेक्ट्रिक से, ये वाला पार्ट तो ग्लास डाइलेक्ट्रिक से फिल किया, ये वाला पार्ट तो व्हाट वी कॉल एयर से छोड़ दिया, ओके, हवा पे छोड़ दिया, ओके, दैट इज फिल्ड विथ एयर। देन इफ द डाइलेक्ट्रिक स्ट्रेंथ ऑफ एयर कितना 30 किलोवाट पर 1 सेंटीमीटर, इसका 300 केवी पर 1 सेंटीमीटर है, तो पूरा सर्क्यूट का व्हाट इज दैट ब्रेकडाउन वोल्टेज कितना होता है। लिसन हियर, it is equivalent to what, 2 capacitors connected in series। ओके, आपका C1 क्या होता है सर, ε1 एरिया ऑफ द प्लेट, लेंथ सेम है तो एरिया ये ले लो बाय डिस्टेंस d1। C2 क्या होता है सर, ε2 एरिया बाय डिस्टेंस d2। इस वाला क्वेश्चन पे d1 इक्वल टू d2 ले लो, क्योंकि दोनों डिस्टेंसेस सेम। देन C1 बाई C1 इक्वल टू C1 बाई C2 कितना होता है सर, ये डी कैंसिल्स, E1 बाई E2 1/4। हियर आई एम राइटिंग C1 बाई C2 कितना 1/4 होता है। आप ले लो इसमें V1 और V2। हमेशा मैंने बताया ना C1 बाई C2 सीरीज में क्या होता है सर फॉर कैपेसिटर V2 बाई V1। इसका मतलब V2 क्या होता है सर 4 टाइम्स V1। ओके, सॉरी V2 क्या होता है सर V1/4। ठीक है, सो V2 इक्वल टू V1/4 और V1 इक्वल टू 4V2। ये रिलेशन मैंने डिराइव किया बेस्ड ऑन द कैपेसिटर फार्मूला बिकॉज द डिस्टेंस इज सेम। अभी क्या करना, कैलकुलेट करना ब्रेकडाउन वोल्टेज। सो ब्रेकडाउन वोल्टेज, ओके, फॉर एयर आपका डिस्टेंस कितना एयर का 0.5 सेंटीमीटर, क्योंकि 5 mm है ना, कितना होता है सर डिस्टेंस इज 0.5 सेंटीमीटर। स्ट्रेंथ कितना दिया एग्जामिनर 30 kV इंटू 0.5, आपको आएगा 15 kV। ठीक है, सिमिलरली आपका ग्लास का क्या होता है सर, डिस्टेंस तो 0.5 सेम, बट आपका VBD कितना इस केस में 150 kV, क्योंकि एग्जामिनर हैज गिवन इट इज 300 kV पर सेंटीमीटर। ठीक है, सो लिसन हियर, दिस इज योर C1 C2, ये आपका V1, ये आपका V2 इज इक्वल टू V1/2। अभी एग्जामिनर ने क्या दिया, इट कैन बी अप टू 15 किलोवोल्ट्स, इट कैन बी अप टू 150 किलोवोल्ट्स। ध्यान से सुनो, इफ V1 इक्वल टू 15 kV, V2 कितना होता है सर 15/4, दैट इज 3.75 kV। आपका V कितना होता है सर 18.75 किलो वोल्ट। नेक्स्ट, दिस इज करेक्ट। सिमिलरली इफ V1 इज इक्वल टू V2 इक्वल टू 150 ले लो, बिकॉज V2 तो 150 तक ले सकते ना, V1 क्या होता है सर? 4 times 150. इसमें काम नहीं चलेगा, गलत है। सो दोनों केस कौन सा सेटिस्फाई करेगा वो आपका आंसर होता है हमेशा। सो 18.75 वोल्ट्स किलो वोल्ट्स तक आप अप्लाई कर सकते हैं। इससे ज़्यादा अप्लाई किया तो V2 इज ऑलवेज सेफ बिकॉज इट कैन टेक अप टू 150, बट V1 चलेगा। ठीक है, एवरी टाइम यू शुड चेक बोथ द केसेस, विच एवर गिव्स यू बोथ सेफ, दैट इज योर आंसर। दोनों बोथ सेफ दिया तो मैक्सिमम ले लो। ओके, इज इट फाइन? Right. Any query you can feel free to ask, नहीं है तो we can end up the session for today. Any kind of queries guys? फिर शाम पे मिलेगा नेटवर्क थ्योरम्स के बारे में। Comment guys. Any kind of doubt you can ask me, otherwise we can end the session. Very good. Okay. चलो देन ये वाला क्वेश्चन आपके लिए होमवर्क दे रहा हूं मैंने, आप लोग घर पे ट्राई कर लो, ठीक है? एंड so these are the batches taken by our top, we all top educators are taking these batches. You can go through them in Unacademy plus subscribed students. As I told you, Evolve and Ascent batches are going to start today. You can take the subscription, sorry, yesterday it is started, by using the coupon code Shankar10. Okay, so for the notes and all you can go through the Telegram channel. इसमें already हमारा notes तो है, मैंने पहले upload किया, you can go through it. नहीं तो नया वाला भी है, मैं तो अपलोड करेगा। टेलीग्राम चैनल पे जाओ, ये वाला टेलीग्राम चैनल फॉलो करो, इसके बाद इस पे जाके फाइल्स पर देखो, आपको नोट्स मिलेगा, ठीक है? सो राइट, सो these are the channels, follow and share and subscribe to more and more number of students so that every single student is able to learn, right? We are the only channel, I think, as per my knowledge, who is giving you the complete syllabus in all best possible ways in free content guys. So don't miss it, utilize this opportunity, study well. Okay, you can use the coupon code Shankar10 whether for the free classes, special classes, live test series, anywhere in Unacademy app, whenever you download it. For free classes access or plus subscription, use my coupon code. Okay, thank you guys. फिर मिलेगा कल क्लास पे, कल नहीं शाम पे. Today evening we will meet again at 5:30 for network theorems. Okay, today 5:30 फिर मिलेगा network theorems के लिए. Thank you. संतान, it is a slope y2 minus y1 by x2 minus x1. y equal to mx का इक्वेशन लिखो, ठीक है? Thank you very much. Love you all. Bye bye.